All right, I wanted to do just a short video on domain, just as a little refresher for those who need it. So just a reminder, domain is simply the set of all inputs, or x values, that give us a real number output or y values. So often people say domain are all the x values. That's half true. It's the x values that give us a real number output. Okay, so essentially what we need to do, we're going to look at equations. We're not looking at a graph to find domain. We're just looking at the equation, and based on what we know about that equation, we want to figure out what the domain is. So for instance, we have f of x equals 2x plus 1. If you think about that, you should know that that's a line because it's in the form y equals mx plus b. As such, if you think about the graph of a line, that line goes on forever and ever, and the domain would be all real numbers. However, another way I think about it is I personally think about, I problem solve and try to decide, is there any x value that I can put into this equation, so 2x plus 1, that would give me a y value that is not a real number. So for instance, if I put 1,000 in, 2 times 1,000 plus 1, that should still be a real number. The real number, or the reason for that, is because when you multiply two real numbers, 2 is a real number, and x has to be a real number. If you multiply two real numbers together, you always get a real number. And then if you add a real number to a real number, you get a real number. Okay, so this is all real numbers. This is the symbol for all real numbers. Let's go on to our second one. So in this one we have h of x is equal to the square root of x plus 1. This is a square root function. Some of you may remember that this function is like a sideways half parabola, like so. Even if you don't know that, hopefully you remember that if this expression inside the square root is negative, then we would get an imaginary number. And imaginary numbers obviously are not real number outputs. Okay, so the boundary between a negative and a positive number is 0. Now you can take the square root of 0, so I just need to make sure that this expression x plus 1 is greater than or equal to 0, which if I solve for x, that tells me x has to be greater than or equal to -1. So this tells me my domain are all x values that are greater than or equal to -1. So I can put in -0.9 and I'd still get a real number output. I can put in 0 for x and still get a real number output. I can put in -1. In fact, I'll just do that really quick. So if I put in -1, -1 plus 1, the square root of -1 plus 1, you get the square root of 0, which is 0. That is still a real number output. However, this is also saying that anything below -1, so if I put -2 in, I would get an imaginary number or something that's not real. Okay, so those are our two domains. We're just going to do a few more just to make that clear. So here we have j of x. It's 2 over x plus 1. Remember, we want to make sure that we want to see if there are any x values that we can plug into this function that would give us something that is not real. Now, if you know anything about division, there's one number that you cannot divide by. So since we're dealing with division, we can't divide by 0. That means this expression in the denominator, the x plus 2, is not allowed to equal 0, cannot equal 0. Therefore, x itself cannot equal -2 if we solve for x. Okay. So our domain would be x cannot equal -2 for this specific problem. Now, with division, you can plug in anything else, though. So I could put in a +1 in for x, and I'd get a real number. The only restriction with division is that you can't divide by 0, and so that's where we have this domain restriction. In fact, we'll do this problem right here, h of x. Notice we have x divided by square root of x minus 4. Now remember, if you have a square root and there's division, so those are two different functions that have domain restrictions. So let's talk about just the square root. So we know that any expression inside that square root cannot be a negative number, which means it has to be greater than or equal to 0. So in this case, x has to be greater than or equal to 4. However, if you check and you plug 4 into this equation, I'm going to do that in a different color down here. So we have 4, I'm putting 4 in for x, over square root of 4 minus 4. We get 4 over the square root of 0, which is just 4 over 0. Now, since there was that division as well, we have to change this inequality just slightly to take into consideration both the square root and the fact that we're dividing by a square root. So since the square root's also on the bottom, we also need to make sure it does not equal 0. So you just take that equal sign away. And now this works. If I put in, for instance, 5 would work because we don't get 0 on the bottom, and we'd get a positive value inside that square root. So this right here, x is greater than 4, ends up being your domain. Last one over here, we have x cubed plus 5x plus 4. That's our j of x function. Now cubes, you can cube a real number and always get a real number back. You can always multiply, we already talked about that, any two real numbers, and you always get a real number back. And adding any two real numbers gives you a real number in the end. So for that reason, there are no restrictions, so this is all real numbers. Ultimately, the real two big things you need to look out for at this point in the year, we're going to find more functions. But the first function are called rational functions. That's where you see division. So I'm just going to put division as a shorthand. So rational functions where the variable is in the denominator. And then square root functions or any even roots functions, because you can get imaginary numbers. Those are the only functions you've encountered so far in your mathematical career. There are more that have domain restrictions, but those are the only two so far that we've talked about. So there's a quick explanation of how to find domain.